Welcome to RGES Algebra 1. This is Lesson 8A. We're dealing with 4.3 and 4.4. Both of these are continuing on with techniques for solving equations when we have variables on both sides of the equation and when we have decimals that we might be involved with also. I'll show you two different techniques. Now this is the basic technique we're going to be using as we solve our equations. You simplify each side of the equation by gathering like terms. You pull the constants to the right of the equation. You pull the variables to the left of the equation. And then you do the last multiplication or division if it's needed. So this is just providing more examples because we haven't had to use all of those steps up till now. Notice in the first example problem, we do not have to simplify the left and right sides of the equation because like terms are already gathered. We need to pull our constants to the right, but there are no constants in the left-hand side of the equation. We need to pull our variables to the left, and this is the first time you've seen variables on the right side of the equation. We'll simply move those to the left. Right now we are having a positive 5x on the right, or we're adding that 5x, so now we want to subtract it from both sides. 7x minus 5x is 2x. Of course, the 5x on the right side will disappear because I've taken 5x minus 5x, and I'll have that equal 18. Finally, do your last division. Divide by 2, and x equals 9. To check that, of course, all we would do is plug it back in. 7 times 9 is 63 equals, and we're asking, does it equal 5 times 9 or 45 plus 18? Well, 45 plus 20 would be 65, and we're too shy of that, so indeed that equals. So let's do a couple more example problems. The second problem is very similar. Little bit different because we don't begin with any constant on the right-hand side, but that will not dismay us. We are going to simplify the left side and simplify the right side by gathering like terms, but in this case they're already gathered. We're going to move our constants to the right side by subtracting 55. We are going to move our variable to the left side by subtracting 8. 3x minus 8x, be careful with your signs, is going to be a negative 5x equals negative 55. And finally, we're going to subtract by divide by a negative 5, and that will leave me with negative divided by negative is positive, and 55 divided by 5 is 11. Mentally going ahead to check that, I'm going to get 3 times 11, or 33, plus 55, does that equal 8 times 11, or 88? Well, you can see very quickly at a glance that it does. Let's do another example. Well, this is kind of an odd statement. We have x equals x plus 5. What would I plug in to the x? If I plugged in a positive number like 3, could 3 equal 3 plus 5? No. What about a 0? 0 equals 0 plus 5? No, that doesn't work. What if I plugged in a negative number, negative 5, let's say? Negative 5 equals negative 5 plus 5, or 0? No, that doesn't work. So just by glancing at it, I see there are no solutions. But let's say I hadn't paused, or it's a complicated one, and I hadn't paused to glance at it. I simply followed through. I can't gather my like terms on the left or the right. I have no constants on the left to move, but I do have a variable on the right to move over, and watch what happens here. X minus x, subtract x from both sides, and I get x minus x, or 0 equals 5. And so when you get something odd like that, when you're done and there is no variable, but I have a false statement, my answer will always be no solution. Now let's look at another one of these kind of odd and aberrant things that aren't the usual. Well, as I look at this at a glance, nothing looks too odd about it, so I'll gather my like terms on the left, and I'll get 5x plus 7, and I'll gather my like terms on the right, and I'll get 5x plus 7, and now that starts looking a little odd. When is 5x plus 7 equal to 5x plus 7? And my answer would be always, and so it would be all solutions. But let's say I didn't notice it. I was just whirling around doing my algebra as quickly as I could. I'll pull my constants to the right. 5x equals 5x. 7 minus 7 is 0. And then I would maybe pull my, this is kind of looking very odd, but if I pulled this to the left, I would subtract it, and I would get 0 equals 0. That's even odder still. But notice what happens here. I have another one of these odd things where we have no variable, but it's a true statement. So when would it be true? True statement. Okay. So when would that be true? Well, it doesn't matter the variable, the value of the variable, because the variable's gone away. Okay, so the answer, whenever you get a true statement, it is all solutions. Doesn't matter what my x or my variable equals. So let's try to put that into practice with one more example problem. Again, if I gave you this, I would move my, I copied the problem wrong. That's more what I wanted to illustrate. So let's move my constant to the right. I would get minus 9x equals, I'm going to subtract minus 9x minus 5. I'll move my variable to the left by adding 9. Negative 9x plus 9x is 0. 0 equals negative 5, a false statement. And so my answer, again, just as above, would be no solution. Now what I'd like you to do is go ahead and glance at the oral practice set on 4.3, page 138 and 139, and those should be pretty clear cut to you. Then go ahead and do your odd problems 1 through 44, and bring any questions you have to class after you check those with the back, and then I'd go ahead and like to do our review techniques together on page 140. Actually, I don't want to do them together. I want you to do all of those. That's where I've assigned all of them, not just the odd, and then come back here to check your answers. Okay, let's see what you might have trouble with here. The first one's pretty straightforward, but of course, it's a distribution. You'll have 3 terms when you're done. The trick would be, of course, that you can make sure you can multiply by your decimal and by your fraction. The next one is simply a gathering of like terms. The next one, again, multiplying 4 times 0.3 would give you 1.2. Just do the multiplication. 4 times 3 is 12. And then make sure that you, of course, pull it over 1. Okay, so 11 minus 2 would be 9. And, of course, to that 0.2 would need 0.8 there. Okay, now for the next one, I kind of like, well, excuse me, I'm trying to pull this down here. 30%. To do that in my head, what I like to do is take 10%. Well, 10% of 400 is 40, so 30% would be 3 times that, or 120. The next one is just a distribution and gathering of terms. Nothing too tricky except this negative sign here. And so when you make sure that it's going to be a negative for the first term and a positive for the next term, and then, of course, you're adding your constants, you're having a negative plus a positive, so you'll take the difference. 28 minus 22 would be 6, and then the 10 minus 6 would be 4. So really available to do in your head. The last one, I didn't have room to copy the first problem, or the problem itself, but it's a 4 plus x plus 3, and we want to commute That means change places between the x and the 3, so you end up with 4 plus 3 plus 4. 4 plus 3 plus x, excuse me. Okay, so on the next page then we're going to go on to 4.4. Now in 4.4 it talks about dealing with decimals. However, part of this I will teach a little different than he does. I want you to keep all answers as improper fractions reduced. Keep as improper fractions, but in their reduced form, unless the problem itself has decimals in it. Okay, improper fractions reduced. Unless the problem itself already has decimals. Okay, so that's going to be our rule of thumb. So this first example they give you, 17x plus 38 equals negative 24. I'll simply move that over and then divide by 17, and I will get x equals negative 62 over 17. 17 is prime. It does not go evenly into 62. And so this is my happy answer. I want you to leave it just like that. However, when I get to something like this, I will move that this way. So I'll get 5.2x equals, I'm going to add 8, okay, 26. I'm going to add 26.3 to a negative 8, so I'll take the difference. That will end up being 18.3. I'm going to subtract 0.47. So if you don't want to try to do that in your head, go ahead and do it on paper. I would turn that 5.2 to 5.20. So when you divide, then you're going to say x equals 18.3 divided by 4.73. Now, actually, it's just fine for me if you want to use a calculator at that point. That's okay, provided your work is shown everywhere else. Otherwise, because I have 2 decimals in the bottom, recall that it would be, my divisor wants to be a whole number, so I would move the numerator over 2 decimal places, getting me 18.30, and then I would go ahead and do my long division. But like I say, if you want to use a calculator at that point, please feel free to. We're going to review rounding to 2 places. Let's go ahead and take your book out, 4.4, page 143. Just a little review with you in rounding. Recall the first one here. The way we do this, if we're saying 3.127 and we want to round 2 places, this is the one I'm paying attention to, and this is the one I'm looking to for my answer. Okay, so the question is, does it remain a 3.12 or does it go up to a 3.13? This will be the only one that's changing. It will go up if this is 5 or greater. So in this case, it will go up and it's 3.13. I'll look at one more with you for review. Hopefully this is stuff you have done a lot of in your previous math. That's a 8 here. 48.582. I'm looking here. This is the one I care about. I'm asking, does it go up to a 9 or remain the same? Since this is less than 5, it remains the same, and that's my rounded version. And I'll just pick one more here. This is a good one, F. If you have 6.497, I'm asking myself, this is the one in question, the place value in question. I'm asking, does it remain the same or go up? It goes up because this is greater than or equal to 5, but now I can't just how do I make a 9 go up? I have to look at this together. 1 greater than 49 is 50. And that's really all there is to the rounding. Make sure your answers are correct. Then I'd like to look at a few divisions here. We're going to look at N. Some very simple review. The directions for this section are use the calculator to find it. So what am I looking for then? I just want to demonstrate the fact that when I'm using my calculator, all I'm going to plug in is 5.4 divided by 0.7, and my answer will be negative. So don't bother getting your sign into your calculator. Here again, I've got a positive divided by negative. My answer's negative, and all I will do will be plug in 0.7 divided by 3.7. Finally, anything 0 over anything is 0, and anything over 0 to divide by 0 is undefined. So you should be able to be square with everything else. When you come back to class, I would like you to go ahead. Actually, I'll just write on the next page the answers to 21 through 30 since you don't have all of those. Okay, these are the answers for 21 through 30. I'll go ahead and check those answers and bring any questions you have to class. And that's all you should need for Lesson 8A.